So solving exponential equations. Um, First, I'm going to show you how to use a common base. So some problems when you look at, you're just going to kind of recognize if you are able to use a common base. So we're going to focus first on bases and exponents. If it doesn't work, I'll make another video explaining how that works. So we're going to use logic and logarithms, kind of, to solve these equations. But essentially, we first want to focus on the bases. So we have, in this first problem, 3 to the x equals 81. We have 3, and we have 81. So we want to know if there's a way to rewrite both of these with a common base. So that means you need to know your powers of 3. 3 to the first power, 3 to the second power, 3 to the third power, 3 to the fourth power. Hey now, there we go. So 3 to the fourth is 81, right? So we can rewrite our problem now as 3 to the x equals 3 to the fourth power, because 81 is 3 to the fourth. So that's how we're substituting that. Well, hopefully this logic makes sense. If your bases are the same, 3 is equal to 3, and they're both being raised to an exponent, then that's going to mean your exponents are going to also have to be equal logically. So in this case, x is 4. That's your answer. So let's do the second one. So we have 5 to the 5x equals 125. So again, we're looking for a common base. 5 to the 5x, we're going to leave. Now, I can write 125 as a power of 5. That's going to be 5 to the third power. Now we have common bases. So, since these bases are equal, that's going to result in these exponents needing to be equal in order for this to be an equation that makes sense. So 5x is going to equal 3. Divide by 5. So x is going to equal 3/5. If you plug that in, you're going to get the same answer. So let's do one more question that's going to be a little more complicated. And the only reason it's complicated is because of the exponents. But, again, we are going to focus on the bases and the exponents first. Bases are 3 and 81. So 3 is going to stay there. We can rewrite 81 as 3 to the fourth power. So I would suggest anytime you're using these exponents, I don't think I did a good job of this before, put your bases in parentheses. It's going to help you organize everything. You can put the exponents in parentheses too. I mean, why not? So on the left, your exponent's going to be 5x. On the right, your exponent's going to be x plus 1. So rules of exponents. Our base, 3, has a power of 1. So our exponent's just going to stay as 5x. On the right side, however, we have 3, and now we have two exponents. We have an exponent of 4, and then another exponent of x plus 1. So that's a power to a power. Whenever you have a power to a power, you need to multiply those exponents. So now we have common bases. Both bases are 3. Those are equal, which means our exponents, 5x, has to be equal to the other exponent, f, or 4 times x plus 1. And now we just solve this as we normally do. Minus 4x. And there's your answer. So again, you could plug it in and check. The left side, when you plug in the 4, is going to be 3 to the 20th power. And on the right side, you would have 81 to the 5th power. If you put those into a calculator, you will see they are, in fact, equivalent. So that's how you use a common base to solve these exponential equations.